Yo, what's up, calculus students? It's Mr. Mester coming at you from my house. Yo, look at this. Special guest appearance. We got Lola, my daughter. Can you say hello to the students?
Hello.
And then Wally over here. What is that you're doing right there, Lola?
Math.
And what are you doing over there, Wally?
Math.
We just got a math table up here. Math party. Math party. All right. So I'm going to be up here doing some calculus. You guys are going to be working on Khan Academy Kids. They have a Khan Academy Kids. And then we got Go Math Volume 1. We're all going to help each other out, though. So if there's questions that you guys have, you let me know. And if I have any questions, I'm going to ask you guys. Okay, and you can help me out.
Okay.
Cool. So we're taking implicit derivatives. We're looking at slopes of these implicit curves. What does it mean to be implicit? It means you have x's and y's on the same side. So implicit curves are like x's and y's on the same side. We have these circles, ellipses, crazy things. And please.
I don't have an answer for that.
We got Alexa showing up here. Please, Wally, can you turn down a couple clicks? Watch the lesson, okay? So you're introduced to this. If you don't watch the lesson, you have no idea what's happening. We're going to get right to it. Taking the derivative of both sides of the equation is something you've been doing, though you haven't been like actually showing it. You get an equation. Like when you had y equals x squared, you took the derivative. A lot of you will just put 2x, but you got the derivative of y was y prime. You get y prime equals 2x, an equation. Here, the derivative of x squared is 2x. The derivative of y squared is 2y dy dx. This is where dy dx comes from. Then we got the derivative of 5, which is 0. What we do now is we either solve for dy dx, or in certain situations, we can plug in our point and find our slope. Here, I'm going to subtract 2x, and I'll divide by 2y to solve for dy dx. Ooh, here's your first question, Lola. You ready?
Yeah.
This is a tricky one. What's 2 divided by 2?
2 divided by 2. 0.
Good idea. Good guess. So, like, how many 2's go into 2?
1.
Yeah, that's it. So, actually, 2 divided by 2 is 1. So, we get that negative 2x over 2y is negative x over y. Okay. Now, if we had points, like at 2, 1, you plug in points into implicit derivatives to get slopes. So examples, I could write the equation of a tangent line y minus 1 equals, if I plug in 2, 1, I get negative 2 x minus 2. And I'm going to graph some of these just because they'll be fun to watch. X squared plus y squared equals 5 is a circle. And at 2, 1 right there, we see the slope was negative 2. Y minus 1 equals negative 2. Watch this, Lola. You see that? What's that a picture of?
Circle.
A circle. And watch this. Negative 2, x minus 2.
What the?
Isn't that cool? It's called a tangent line. That line just touches the circle only at this. One location. One location, tangent. Cool. All right. What we have to be careful about, which a lot of people are not careful about, is your rules still apply. So let's get to it. I don't want to take forever on this video. I could, but I'm just going to start cranking things out. Derivative of the first times the second plus the derivative of the second times the first equals the derivative of the right side. That equal sign, the derivative of the right side, is something that a lot of students will make mistakes on. Try not to make those mistakes. If you'd like to, you could rewrite things so maybe that the stuff is in front of the dy dx but is not required. You would then subtract 2xy squared from both sides. You would then divide by 2yx squared. All right. Simplify if there's a multiplication. Don't simplify if there's addition. Let's write the equation of the tangent here. I think I just asked you for the slope, but it's fun to graph. So, all right, Lola, here's your first question. Ready? Another question. What's
Second.
1 times 1?
1.
Good. What's 3 times 1 times 1?
3 times 1 times 1.
Yep, 3 times 1 times 1.
It's
tricky.
1.
What's 3 times 1? What's 3 ones?
3.
Good. So we got a -3 up top. Now, what is 3 threes? What's 3 times 3?
3. 3 times 3 is 9.
Good. All right, so we get that, which is that. And let's look at our handiwork because it's fun. We have x squared times y squared. Woo! Look at this graph, Lola.
Oh my god.
Oh my gosh. Oh my gosh. And then we have y minus 1 equals -1/3 x minus 3. Right there. There's that tangent. Wally, what are you working on?
I don't know.
Okay.
Just guys.
You're just doing shapes? You're working on your shapes? What shapes do you have to pick?
I forgot. Rectangles. Rectangles.
You know what rectangles are?
Yeah.
All right, good. All right, good. Look at that. I'm doing math. I just said I was going to go fast through the video. All right. I don't see anything crazy going on here. The derivative of 4x is 4. The derivative of 4y is 4 dy dx. This is all good. Factor out the dy dx. Divide by 3y squared plus 4. I can't simplify the 2 and the 4. Don't try to do it. You see this addition down here? Makes things complicated. Y minus 2 equals, let's plug in 4, 2. 2 times 4. What's 2 fours? Well, what's 2 fours?
2, 8.
Good. How many times does 8 go into 16?
2.
Nice. How old are you?
7.
Nice.
These are such random questions, Dad.
Some random questions, Dad. I just want to see what these look like.
Okay.
Ooh. There it is right there. Not that interesting a graph. There might be more stuff going on down here. It's not something I can solve for y, though, easily. All right. Don't give you a point, so we're just going to write the expression. Everybody heads up. We see a product We also see the negative. Here's what I like to do. Bake in the negative. You can leave it out. I like to bake it in. If you leave it out, great. If you bake it in, this is what it would look like. The derivative of negative 2x times y plus the derivative of y times negative 2x. It's important to kind of understand you're multiplying things. Probably a good idea, derivative of y squared, derivative of 2, is to rewrite this so that
13.
the 2x is in front of the dy dx.
So,
Now, immediately, there's something I notice I can do, which you could do now or you could do later. Like you could divide everything by 2. Dividing everything by 2 is something we'll do a lot actually this unit. We're going to be dealing with the Pythagorean theorem. So we'll be able to just like cancel a lot of 2's if we have like a lot of derivatives.
canceling 2's is really good because 2's are such boring numbers.
2's are such boring numbers, and if we want to get rid of them, like let's get rid of them.
Yeah, let's get rid of all of them.
Let's get rid of
And
them.
we just go 1, 3, 4, 5.
That's what I want to do. Okay, so I'm going to subtract the x, add the y to both sides of the equation. I have negative x dy dx plus y dy dx equals negative x plus y. I'm going to factor out the dy dx divide to solve. What is going on here? I feel like this equation is an equation that's actually
What equation?
x squared minus 2xy plus y squared equals 2. Holy cow! I don't remember this. This is wild. There are 2 parallel lines. I'm certain I've seen this and understand this. But I forgot. Is it because it's x plus y squared? No. X minus y squared. Is it the fact that I put a 2 here, made it an x minus y squared, which can be square rooted, which means we get x minus y equals plus or minus root 2, which is why we get y equals x plus or minus root 2. Holy cow. Like, I just rewrote that equation as a linear system. Y equals x plus root 2. Y equals x minus root 2. Root 2 is, this is wild, 1.414. There's x plus root 2. There's x minus root 2. Their slopes are 1. Weird. This doesn't really happen ever. It's not going to happen for any others. So you won't see a 2 there. It won't be something like that. Usually you'll just get an expression with like 2x plus y and then minus x plus 2y or something like that. Oh, you guys hate square roots, but you have to suck it up and deal with them. You know what a square root of is, Lola?
No, I'm not even in high school.
I know. So let me try to explain it to you. Ready? What's 3 3s?
3 3s are 9.
So what we say, Lola, is that like 3 squared is like 3 3s.
Yeah.
Does that make sense?
Oh.
Okay, so like take 3, make it a square, you get 9. So like what's 4 turned into a square? 4 squared.
4 turned into a square would just be the terrible 2s.
No, that's 4 split in half. What if you put 4 and make it in a square with like 4 4s?
You could have 4 1s, but you couldn't have 4 4s.
4 4s though. Do you know what 4 4s are?
16.
All right, so 4 4s are 16. So square roots takes a number and brings it back to like the original. So if I ask you what the square root of 16 is, the square root of 16 is 4 because 4 fours are 16. So what do you think the square root of 25 is? Take 25
Oh, the
and
square-
bring it back into its like pieces.
5 5.
5, yeah, exactly. The square root of 25 is 5. All right. So you get it.
I kind of.
Yeah.
No,
We got
I get a prize.
You got plenty of time.
I get a prize. Perfect.
What prize did you get, Why?
Why don't I get anything for all of them? You know, let me see his bathtub. 1. Oh, look at. You don't have a lot, mister.
Why, before we go, you got to show everybody all your prizes.
You only get 26, you should have like 50.
Well, Wally doesn't like the bath toys. He likes the instruments.
I like the bath toys. I like the hat and the bath. Wait, I like the hat and the instruments.
Factor out dydx. This is one of those where like I feel like I'm going to be able to simplify this, or else it's going to look gross. If you have dydx's on both sides, get them on one side, then factor them out. Get everything else without a dydx onto the other side. Yeah, I feel like I make these too hard. This might be the last year I do this particular homework. This one's not that bad. No, it's just sometimes we math teachers make things repetitive and a little bit more difficult, right? Like you're doing a lot of things that are repetitive, right? Sometimes you get a little bit bored in class because you're like, oh, we've done this before. Is that fair?
Oh, yeah, because you've already done this with like your students or something?
Well, sometimes when I give homework assignments, the homework assignments I give are a little repetitive.
They come with a
In
video?
that, like, oh, we're doing this over and over and over again, Mr. Messner. And the key is to give just the right amount at the right level for students, right?
Yeah, yeah.
You don't want it to be too hard. You don't want it to be too easy, right?
Yeah, you want to give it the right amount. That's like that's like what my teacher does for formative loops. She gives us like what we're at.
That's great. Formative loops, love it.
What we're at.
That's where you're at.
We should give calculus formative loops.
I don't even know what a formative loop is.
It's something that you give like a sheet of paper that has stuff that's third grade level, and you just time them for 5 minutes.
Oh, and do you like crush the third grade level stuff because you're in second grade, or do you like? Are you like, oh, this is tough?
It's actually really easy.
Okay. And that kind of lets the teacher know where you stand on things?
Yeah.
Oh,
Kind of
cool.
lets you know where you stand and like
So that's like when I ask students like, hey, can you do this? And then they try to do it and then they all get it wrong. I do that stuff on purpose.
Why?
I don't know, because like a lot of times students are like, oh, I got this. But when they get to calculus, it's a lot harder than they think.
This is calculus.
Yep, this is calculus.
Oh.
All right, we got negative 2 times 2 times 1, which is negative 4. Negative 4 plus 3 over.
This one.
2 squared is 4, minus 3 times 1 squared is 3. So I got negative 1. I want to see this. X squared y minus 3x equals y cubed. Woo! That's fun. Minus 3, shifted down 3. And I'll have y minus 1 equals 1. X minus 2. Negative 1. There it is. Look at that right there. That's cool.
Okay.
Look at this crazy graph with
That's
all these
actually-
things, and then there's a tangent line right there at that point, 2,
The
1.
tangent line.
Tangent line is a line that just touches the function, this graph, at one point. You don't even know about graphs yet, but they're cool. All right. Trigs, don't stress. Think about it with x. Don't stress, think about it with x. Derivative of 2 sine to cosine. The reason why I'm doing this video at home, part of the reason, is because last year you're going to see on the lesson 4 video, I did a video at home. It was right after I got my new hip. And like I just needed to get the video done because I was out. And my students were like, "Oh, that was fun." I'm like, "All right, let's do a videos from home." You can see I have a new hip. I have a completely new hip. My left hip is completely artificial. And last year, I got that new hip. On Thursday, I'm going to see you guys on Thursday, is a 1-year anniversary of me getting a new hip. Wild stuff.
It's an anniversary.
Yeah. Thursday is my 1-year hip anniversary.
Okay,
Remember when I got the new hip last year?
Yeah.
What did I have to do? What do you remember about it?
You had
Anything?
to skip school for like 5 months.
No, I missed 2 days of school total. That was it.
Dad, here's my face.
Yeah, guys, look, it's Wally's school picture. What a smile. God, school pictures are the best. And here's Lola's school picture. Oh, epic smile. I love the headband, Lola. Yeah, we have to, if we keep these pictures, we have to pay for them.
Yeah, they're expensive actually.
Yeah, they are, but whatever. Mommy will get them. I would like them. The grandmas like them too.
Yeah, of course they do.
Yo, product rule, derivative of the first times the second plus the derivative of the second. If the derivative of sine x is cos x, the derivative of sine y is cos y, dy dx. Product rule, nothing crazy here. You're going to subtract the 2 sine y. I'm going to rewrite this right side as cos y 2x dy dx. I could divide everything by a 2 if I wanted to. This 2 would go away, this 2 would go away, this would turn into a 2. You can do that at the end.
So your students all have to write this?
Yeah, they all have to figure this stuff out.
What?
Yeah, it's tricky.
What?
Yeah, they have to do all this homework. And like this isn't even the longest homework of this unit. There's longer homeworks. I don't even want to do that. Tan inverse? Like, what are we doing? Tangent. Why did I give you this? You would never see this on a test. I don't know. Maybe you are. Derivative tangent secant squared. And do this all at once. Ready? Subtract the 3 secant squared x, then divide by the 2 secant squared y.
I want what?
Oh, this is actually the reasoning behind
Oh, I watched this before in Spanish.
arctangent's derivative.
It
Is implicit. I forgot how to derive it, so I'm not going to do it. I don't want to waste time. But like,
una banana, dos bananas, tres bananas, cinco bananas, seis bananas, para mí. You need to turn this.
good Wally.
Yeah, you just hear that. That's so cool.
Multiply both sides by 1 plus y squared.
Turn this down. Oh, sorry. Okay.
I plug in pi over 4.
We don't want it too loud, okay?
16 plus pi squared over 16, or that's it. Maybe I'm going to write it as one fraction. Y minus pi over 4 equals 16 plus pi squared over 16, x minus 1. Let's see what this looks like. I also want to just make sure I'm doing things correctly because I'm kind of not really. Yeah, that's the graph of tan inverse.
2. Oh, yeah. Oh, we had one strawberry. Smoothie.
16 plus.
Good smoothie.
I mean, that's off, isn't it?
So that means let's make it cancer or something. Take away some. Dad, I do moose math.
Yeah, you do moose math, bud.
How do we get there? Like, oh my gosh, baby.
Well, your home button doesn't work, so you got to find the little dot.
Yeah, I see it.
No, you do the bottom one. No, the bottom one.
Hello, Robbie. By the way, it's 7:21
Home.
p.m.
The bottom button?
There.
It's 7:20.
Yep, we gotta go to bed soon.
Wait. But Daddy, we want to draw before doing that thing.
Yeah, you guys can draw before we go to bed, and then I might have to come back and finish the video. It's like I want to take the tangent of both sides.
How much time do you have on that?
I have a lot more to do. It'll get easier, honestly, once I get to this page. Like once I get past this page, this is gonna be pretty easy. So we just gotta get there. But I'm trying to figure out what I did wrong here. The derivative of tan inverse is 1 over 1 plus blank squared. So I have 1 over 1 plus parentheses squared times the derivative of parentheses. So I have that dy dx. I have the y squared, derivative of x, multiplied by 1 plus y squared. I get that. I plug in pi over 4 for y. I get pi squared over 16. 16 plus pi squared over 16. Did I just type that in wrong? Like this is correct. Can you help your brother?
Oh, I got one.
I wonder if there's like now a point.
7.
Yeah, I was wrong. It's the flip-flop points. This should be pi over 4 comma 1. Watch. I bet you that's why.
Bingo!
Bingo. There you go. Look at us getting bingos, Wally. All right. This I do see on your test. Like this is almost the exact same question as you see on a test. It is tricky because the inside being xy requires you to use the product rule. If anything, I would give you more of these where it's like x squared minus xy. I should have given you like more of those. It's like mistakes students make too often. I got cos parentheses. The derivative of xy is the derivative of x times y plus the derivative of y times x. So you get cosine, what starts in parentheses.
I got a bingo.
Oh, cool. So what's that? You got 3 dots and then 2 dots. So what do you get?
5.
Woo! We go up bugs.
What's 7 plus 2?
Well, it's 7 minus 2. So it's like you start with 7, but then 2 go away.
Oh, that's a tricky one. I knew the answer.
All right, now we talked
10.
about this in class. You have a dy dx in here, and you have a dy dx in here. One is stuck inside the parentheses. One is on the other side of the equation. What to do? We did it in class. Distribute. Get y cos xy plus.
Dad, is this going to all your students?
If the students watch it, then great. They'll have it. If they don't watch it, then they're not going to have it. Most of them watch it and just copy down what I write. They don't even actually try. A lot of them do try. Oh, you look so cozy. But yeah. I'm going to move the dy dx's onto the other side. Yo, heads up. If you move the dy dx's onto the opposite side of where I have moved the dy dx's, your answers are going to be the opposite of my answers. So heads up. And you might be like, why is this the opposite? Like, let's say you, probably for this one, move the dy dx's onto the other side. You would have gotten a positive here, a negative here, and a positive here.
Bingo?
You're right. It's just like we have a -1 over a -1 factored out. Same with this guy. Let's say you moved everything to the other side. You'd have a positive, a negative, positive. You still get the right answers. Okay? So I'm moving the dy dx onto that side.
Bingo.
Well, I pop over. That way we can see your bingos.
Wait.
Ooh, what's that question, Wally?
3 take 1 away.
So we got 5
Yeah.
minus 3. See?
6. Oh my god! I thought it was 6.
I don't think it was 6. You're just guessing. There, wait. Stop guessing. 9. Start with 9, Wally. And then take away 6.
Take away 6.
All right, so start taking away 6. Okay, 1, 2, 3, 4, 5 are gone. Now let's take away 1 more. How many do we have left?
3.
Yeah, these are tough, Wally. You're not ready for subtraction yet. We're still working on like 4 plus 4.
8. What?
You're just guessing. Don't get mad at me. Wally, wait. Stop. Stop, you're guessing.
I'm making it harder.
I'm not making it harder. You're just guessing. What's 10 minus 3?
I know.
All right, we got to take a break. All right, we're going to go to bed after we do this problem. This is a bad one to do anyway, so skip it. All right, we'll be back after quick little drawing break. Loa,
Yeah.
take it away.
Bye-bye.
What do you want to show? So here's the things right there.
I forgot how to do it.
You just gotta click on a pen. Here, do you want the highlighter? There you go. Now you can draw.
Yeah.
Is that a bird?
No.
Oh.
Where's the eraser?
Yeah, don't worry about it.
I need the eraser.
We can't spend forever doing this. I gotta get to this page and then the last page. Here, you want me to do the eraser? That's the eraser. You want a green pen?
No, I need a pink pen.
Pink pen.
Can I try something?
Why don't you write like a little note for the students? Okay. All right. So let's find a pink pen for you, and then you can write a little note for the students, and then Wally, you can write a little note for the students, and then we're gonna go to bed. I'll
Who's
finish
gonna
this reading.
write anyway?
Well, say like, hold on, Wally.
I'm gonna do
Oh.
rainbow.
Tell them good luck. Tell them, nice doing math with you. Saying, you can say, I heart math. Epic. And you know what we need? Some smiley faces.
I want to do them.
Okay. You can pick from anything right here, like stars. Okay. And then Wally, you can finish off the decorations. Oh, what happened? There, now try. Yeah.
Hey.
You can hold it down too. Oh, nice! Nice little smiley face, smiley face. All right, Wally. What would you like? You want rainbows? You want stars?
Can I choose the color?
Yeah, do you want a color?
Yeah.
Okay, what color do you want?
How do you do this?
What, Wally, what are you doing? All right, let's go to the pen, and then let's go
Hey,
to
you're
which
putting
color.
my message.
I know, we'll move it. Don't
I
worry.
want to do. Wait. Can I redo it?
No.
I want to.
Can I just at least do the
Can I
math?
erase this?
Yeah, I'll erase some stuff. What do you want to erase? Yeah, let's erase this.
I want to erase like all of it.
No, not all of it.
What? This smile. This
This is fine. Look, this smiley face is not hurting anybody. You can add, not delete, okay?
Okay.
So, what color would you like? Or do you want a creative pen?
I want to create a pen.
All right, so here is the creative pen.
Rainbow pen.
You want the rainbow pen. All right, now here is your pen.
Okay.
Okay.
What do I need to write?
Whatever you want to. I would say like just add. Don't
Can I write my name?
erase. Yeah, you can write your name. Start right over here. There you go. Wait,
Smiley.
how's that the smiley face? Let's make this a little thinner.
Smiley
right.
faces.
Oh, that didn't work. It's got to be a little bit bigger. Sorry, students. Hope you're enjoying this.
Hi, Studio. Studio. I'm so close to you. Why? Why do you do math all the time?
I'm a math teacher, kid.
Because you already do math. That's why. I can't see you guys.
Okay, Buggy, now it's working.
All right, there you go. I already did the W. You can keep going from there.
The A.
Yep.
LLY.
I don't know that. I have a lowercase a. Do I press this button to draw?
You kind of hover, so move it really close. That way you can see where you are. There you are, right there. Now you can draw the A. Yes, good A. Okay. Yep. L. L. Whoa. What? There you back. Okay, try it a little bit lower. A little bit lower. Whoa. Hold on, let me fix it.
Sorry, students. That was
All
my.
right, start right here. Up. L. And let's do a Y right here.
I can do Y.
I know you're doing really
Can I
good.
write my name too?
Sure. All right, here's Wally.
Now
and then-
smiley faces. Smiley faces.
No, Lola's gonna write her name and then we're gonna call it. You guys are gonna go to bed.
No, why can I not read?
Oh, I know. Well, you've been doing math, kid, so we can read a quick little book. These are stars.
You want to do stars for their name? Okay, star. Huh?
Try over here.
Yikes, what am I doing?
It's switched up.
Joe, not Joe.
There you
Now you're on snowflakes. You're a snowflake. I'm a snowflake. I'm a snowflake.
All right, I heart math.
Everything.
I heart math. No, it's great. This looks great.
Oh, no,
Hey.
everything.
It looks great. What are you talking about? Say goodbye to my students. Thank you for helping. Lola, can you say goodbye?
Goodbye. Bye.
Okay, great. I think it looks great. What's wrong? Which one? What do you want me to get rid of?
It's covering the T.
All right, well, I'll get it out of the way. Look. See?
Thank you.
All right, no problem. I heart math.
6.
Representing.
6.
Wally
5,
and Lola.
4, 5.
Looks good. See? Isn't that cool?
All
right. You did a great job. Pause. All right. Kids are in bed. So we gotta keep quiet. What do we talk about? Yeah, I wish we had more ellipses. That's all. Like product rules, but with a minus sign in front. That guy. Hey. If you're gonna know anything for your test, like make sure you know how to do that guy. You'll see that guy. Like product rules show up a lot. All these other ones I'm throwing at you, like you'll see one or two of them. For example, this one you'll see on the test. I don't know about those guys though. Just do them anyways. Derivative of e to the x is e to the x. Derivative of e to the y is e to the y times dy dx. Subtract e to the x. Divide by e to the y. Okay, plugging in 0, 0, you get 2. You can look at the graph. Derivative of this guy. E to the y's derivative is e to the y times dy dx. Again, where these implicit derivatives really make students have problems is when you combine like chain rules with the dy dx's or chain rules and product rules and stuff like that. I got a minus, I get this 3y squared e to the y cubed times dy dx. I only have dy dx's on the right side, which is nice. We could factor, divide to solve. This one's an important one. I think this one shows up on the test, something like this. And this one really messes up a lot of students for multiple reasons. Derivative of the right side, let's just work on first. E plus 4, a lot of people are thinking the derivative of e is e, and it's actually wrong. I think we had these in our notes. We might not have gotten to it completely, but e plus 4 is a number. 4 plus 2.717, which means its derivative is 0. We just have to be ready for that. Derivative of e to the xy. I'm going to use the own I, and I'm going to realize that I's derivative is a product. Okay, so let's give some space here. So I got e to the xy times y plus dy dx x plus 2y dy dx equals 0. Now, we could have talked about it earlier. We didn't. Sometimes, depending on the situation, it is beneficial to plug in the point earlier instead of finding what dy dx is equal to. This would be one of those times. If I plug in 1/2 and 2, I'd get e times 2 plus a half of an x, dy dx. I get 4 dy dx. And it's still a little tricky, but we can combine these after distributing. And this would be like the same thing you did if you didn't. We're going to skip this one. Just skip that one. Subtract 2e. This one you're not going to see. This one you're going to see. Subtract 2e. Factor out the dy dx. Divide to solve. And this is good. This is fine. However, this happens on the test. You might not see an answer like this where there's a fraction inside of a fraction. We need to multiply the top and bottom by a number to remove the whole fraction inside of a fraction. Why am I multiplying by 2? Because e over 2 times 2 is just e. So just by doing this, I can write this as negative 4e over e plus 8. This problem with an answer just like this is on your test, guaranteed. Okay? It's tricky, so heads up. These logs, sometimes tricky. This one not as bad as the other one. The derivative of log y is 1 over y times dy dx. The derivative of log x is 1 over x. This would be a great example of just plugging in 1, 1. Because we don't have to worry about the fractions inside of fractions when plugging in 1, 1. Just add 3 dy dx's to this dy dx. I get 4 dy dx's. Divide by 4, I get a half. I want to just see that. See if this equation is interesting. Probably isn't because log x and log y have a restricted domain. Oh, it's fine. It's got a little curve in it. Oh yeah, look at you. Cool. And I got the equation y minus 1 equals, what's it, 2? A half? X minus 1. Oh, that's obviously wrong. It's a minus. Oh, it's not as exciting. Nah, oh, it works. Just having this a minus makes it a lot less exciting. But there you go. Right. As expected. It's so complicated that it's tough to even see that 0.11. think my daughter's sick. She has a cough. It's not fun. Wally's sick, but he's on antibiotics. He has a sinus infection. Lola probably has something like that too, so we have to take her to the doctors. It's too much stuff going around. I know you guys have all been sick. So many of you have been out. I've been fortunate. So far, I have not been that sick. I had a little cold in between ACLs. Okay, this is one of those examples where you got a dydx on the left side, you got dydx inside parentheses. The best thing to do is to distribute. Now, when I distribute, I actually can make some quick little adjustments / simplifications. These y's do cancel. These x's cancel. So subtract dy dx times 1 over y. Just algebra. Hope we understood it from the lesson. You know, we had plenty of time to go over it. Reminder, next class, this is 2023 we're talking about. If this video exists for next year, though, I'll probably change it up the homework for next year. You have a quiz on Thursday. We don't have a lesson over the break. All right, cool. Last page just deals with, oh, good. Yo, this one. Should we do this one? Oh, but this is the mistake. The minus 2y means this is, the slope's going to be y. I got to change this. I'm going to write out a little note. This is how I make adjustments for future years. Oh, I can't because it's not. I'll just write a note. Tomorrow. Let's change this, please. It's like a minus 3x. Or minus 4xy. Cool. And let's talk about the 0.10 or something. Simple. About the 0.41. And we will approximate 0.75. And I change this to a 4. Because if you have minus 2x, it's this parallel line situation, which is so trippy. It's like crazy. Change that number like to just an x and it's an ellipse, you know, it's like, it's wild. Anyways, oh, I heart math. Lola was upset that Wally covered up her I Heart Math. It's cute. She was like, it's covering it up. All right, let's do this one. This one does work. You got to O and I this. Derivative log. You want some cough medicine, kid?
I'm not sure.
I think you do. We're going to get you some cough medicine. This is an example of like, you don't always have to distribute to get rid of parentheses. You don't have a dy dx on this side. I'm going to multiply by x squared plus y squared. Now, what that enables us to do is like, this goes away. Like, it's dividing by x squared plus y squared, multiplied by x squared plus y squared. That goes away. And we get this. And then all of a sudden, it's like, subtract 2x, divide by 2y. This is no big deal. Okay? There's a test question where it's like, this is the way you do it. Like, get rid of that simple thing in like a denominator, because there's no dy dx on the other side. We don't have to distribute. We plug in 0, 1. I get 0, 1, 0, 2. So we get a half. So we have y minus 1 equals a half x minus 0 if I want to approximate a y coordinate on the graph. Well, it's okay to cough. Like, go ahead and do it. I know you're sick. We're going to get you better. We're going to take you to the doctor, okay? I don't know, maybe tomorrow, maybe the next day. Hopefully we can get you meds before we go to Atlanta. This will be interesting because I can plug in any x's or y's and it works, which makes it the log of positives. So, like, there you go. That's a fun little curve. And then we have our equation. Y minus 1 equals a half x. I don't like how it's in red as well. There you go. And if I zoom in, the line mimics the curve really close to this location. And that's what we learned last unit. And let's finish off with this one. If you did this without looking at the video, great. If you're doing it now, it's the time to like really make sure you do it. All those things that we like worked on in class, like, hey, you're going to try this. Yep, you're going to be wrong. Okay, now try it now. Okay, you're still wrong. Like, now we can get it right. Let's get it right. What do we have to worry about? Two things. That negative and this product rule. The other things we have to worry about. The equal sign disappears on people. The number, the derivative is 0. It's not, doesn't stay as 1. Big mistakes, like people will make it. This is not minus 4x. This is dy dx times negative 4x. That's the one kind of like worry about baking things in. Take advantage of the fact that you see 2's everywhere. Maybe you can divide everything by 2 right off the bat. You could do it later as well. I'm going to subtract the x, add the 2y to both sides. Going to factor out the dy dx from the remaining terms. I will divide to solve. You see this? You want to simplify it. Don't. The plus prevents you from doing it, so don't do it. You can just plug in 4-1. We could have plugged in 4-1 earlier. I don't know how beneficial it would have been. Ooh, that's fun. 2/7. Let's make sure it looks good. Didn't make a mistake. This is something like I appreciate when making homework videos, is like making sure I get the right answer. All right, we got this hyperbola, not an ellipse. So I get y minus 1 equals 2/7 x minus 4. Wow, yeah, that looks good. Right at this point, 4-1. Okay. Crazy. All right. So my equation, again, of my changed thing, because the other way was wrong, but it was fun to see that. All right, pay attention to this. Like, this is an x, this is a y. Now, I'm changing it to k, kind of 0.75. So that's an x, that's a y. We want to plug in 0.75 for y and solve for x, which you can replace with k or just be like x. Okay, so this is -1/4. I don't know if we want to distribute the 2/7 or not. I feel like we don't. I don't want to. You could solve that fine. It's just like kind of just thinking ahead of like what's going to be easier to solve. And it's like having a -8/7 and all -1/4. I don't know. It'll probably be the same. I'm going to multiply by the 7/2, get rid of that, giving me -7/8 equals k minus 4. I'm going to add 4, which is 32/8. 32 minus 7 is 25/8. Let's see. When the y coordinate is 0.75, the x coordinate is close to 25/8. That's 25/8. When the y coordinate is 0.75. This is one of those things where it's like, which y coordinate are you talking about? We were focusing our attention at the 0.41. So we're probably talking about this y coordinate. 0.75. There you go. 3.15 versus 3.125. You know, that's like, it's not bad at all. Not bad at all. All right. Hope you enjoyed the little change of pace. Hopefully, you weren't like, can I just get the answers, please? You did. I'm sorry. But it's a busy week, and I don't have any time during the day because I'm out on Friday, and I got videos for those classes that I have to make during all of my conference periods. So just getting this one in, and it kind of works out with the other unit, the other video you're going to see later this unit. Anyways, Thursday, lots of just practice problems and taking a quiz. No homework over the break. Eat your turkey. Enjoy your lives. Enjoy the time off and your family. And everybody wins. We'll see you out there.